You'll have been introduced to this idea of integration as the reverse of the process of differentiation. So a way of undoing a derivative. Just like differentiation, all integrals must be in the form of ax to the power of n. So in this format here. If you don't have it in that format, you cannot integrate. So it means just like differentiation, there should be no square roots or powers on the bottom of a fraction. So here I have got 4 derivatives that I'm going to work through. Each of these will need to be prepared for integration before I can actually do the process. So the first one, I am going to integrate 1 over x to the power of 5 with respect to x. So notice how I've just written this in a slightly different format. The dx has been just sort of put on top of the fraction in that question. I need to use my laws of indices, my rules of indices. So I am integrating x to the negative 5 with respect to x. So the x has come up to the top of the fraction, and as it's done that, the 5 has had to change to a negative 5. I've still got my integral symbol because I haven't done any integration yet. All I've done is I've prepared it for integration. Now I'm going to go forwards and actually perform the integration. So to do that, I need to take the power and increase it by 1. So my negative 5 will increase to negative 4. I now need to divide by that new power. There are a couple of ways you can write this. Because we are dividing by negative 4, I quite like just putting a quarter as my coefficient and then just popping my negative symbol in. Now, because we have integrated, we need to remember this plus c for the constant of integration at the end there. That's us done our integration. It's always useful to rewrite it in the original format. So here we've got it written as a positive power, so I'm going to do the same here. So I'm going to take the x to the power of 4. He is going to move down to the bottom of this fraction, and it's going to become positive 4. Because remember, what's really happening here is I've got x over 1 there. So it's moved down and become a denominator. The plus c, I need this at every step, so the plus c also gets included. Second one, b, is also using our rules of indices. I have got 4 lots of the cubic root of x to the power of 5, and I'm going to integrate that with respect to x. So just like before, I need to rewrite this with a power, get rid of that root symbol. So I'm going to integrate. The 4 isn't going to change. I've got x to the power of 5, and I can say this is the third root, so I'm dealing with thirds. So I've got 4x to the power of 5 thirds. I'm going to integrate that with respect to x. Coefficient of 4, that doesn't change what I'm doing. I'm dealing with an x, and I need to increase the power by 1. So I have got 5 thirds, and I'm increasing it by 1 whole, by 3 thirds. So that takes this up to 8 over 3. I now need to divide by this new power. Remember, to divide by a fraction, we can multiply by the reciprocal. So I'm not going to write divided by 8 thirds, I'm going to write multiplied by 3 over 8. I also need to remember plus c. That's all the integration being performed there. All I need to do now is tidy it up a bit. So I've got this 3/8 times 4. Well, rather than doing any multiplication, I can simplify this. I can divide that by 4 and that by 4. So I've got 3 over 2 lots of x to the power of 8/3 plus c. Again, just rewriting this in the same format, I've got x to the power of 8, and because this is thirds, I can write that as the third root, the cubic root. And I've got my plus c at the end there. C and D are a little bit more complicated, but at their heart it's the same problem. I need to take these functions, and before I can integrate them, I need to break them down into ax to the power of n, but in this case I'm not working with x, I'm working with theta, and I'm working with t, but I am integrating with respect to those variables. So the letter itself doesn't matter, because we're saying what we're integrating with respect to there. The first one is written as a fraction. So question C, theta squared minus 2 theta all over 5 lots of theta to the power of 2/3. So this is going to get quite messy. Before I can integrate that with respect to theta, I need to break it up into little bite-sized chunks. So I'm going to write this as 2 fractions. So I've got my integral symbol, because I haven't done that yet. I've got theta squared over 5 lots of theta to the power of 2/3 minus 2 theta over 5 theta to the 2/3. And I'm going to integrate that with respect to theta. I now need to take these 2 fractions and simplify them. So I've still got my integral symbol because I still need to integrate. I'll deal with the coefficients, the numbers first. I've got 1 over 5, and I can just use my rules of indices here. I've got 2 subtract 2/3, so that's going to be theta to the power of 4/3. Because 2 wholes, well that's 6/3, minus 2/3 will leave me with the 4/3. And I'm going to leave it as a top-heavy fraction rather than a mixed number. So do not write 1 and 1/3. The next one, 2/5 for my coefficient, 2/5, and I've got theta to the power of 1 divided by theta to the power of 2/3. So 1 whole minus 2/3 will leave me with 1/3. And I'm going to integrate that with respect to theta. I have broken the function down to 2 little bite-sized chunks in our required format. So now I can begin integrating. The 1/5 isn't going to change. Theta, my 4/3 needs to be increased by 1. So I'm going to add on 3/3. So I've got 7/3 for my power. I need to divide by 7/3. Well, that is the same as multiplying by 3 over 7. So I'm going to have 3 over 7 times my thing I've integrated. Minus, right, my 2/5. Notice I've left a little space here because I'm going to be working with another fraction again. Theta, I've got 1/3, and I need to increase it by 1 whole, so adding 3/3, that'll give me 4/3. I need to divide by that new power, so instead of dividing by 4/3, I can multiply by 3 over 4. So 3 over 4 times that. And remember, we've integrated, so we need our constant of integration. I'm going to tidy up and leave it in the format the question gave me. The question's given me it with fraction powers, so I'm going to leave these as they are. First one, 3 times 1 will give me 3, 7 fives will give me 35, theta to the power of 7 thirds, minus, now this fraction will actually simplify down. If I divide the top and bottom by 2, I'll get a 1 and a 2 there. So 3 times 1 over 2 times 5, theta to the power of 4 thirds, plus my constant of integration. There's no point trying to rewrite this as a single fraction, because I've done the integration. I've simplified down the two separate fractions. I've remembered my constant. I'm done with that one. D. I'll do that on the next page. With question D, I have been asked to integrate t plus 3 times 2t minus t squared with respect to t. I need to expand those brackets out before I do that. I don't care how you expand brackets. You can use your breaking brackets method, or you can use a grid. I tend to go for the grid method. So I'm going to multiply t plus 3 by 2t minus t squared. So 2t squared plus 6t minus t cubed minus 3t squared. And that is going to tidy up to 6t, 2t squared minus 3t squared, so minus t squared, and minus t cubed at the end. And all of that gets integrated with respect to t. That's the difficult bit done. I've expanded and tidied up my brackets. Now I just integrate each of these little bits with respect to t, one at a time. So 6t, the 6 doesn't change. I've got t to the power of 1 there, so I increase the 1 and divide by that new power. So I'm going to have to find a half of that. Take away t to the power of 2, so I increase the 2 to a 3, and I divide by that new power. Minus t cubed, well, I'm not cubing it, I need to increase that power and divide by that new power. Just check if I can tidy up. Well, I've got a half of 6. That little dot there, that is just another way of writing a multiplication symbol. You often see that when you've got quite messy statements like this. So half of 6 is 3, so I'll have 3t squared minus a third of t cubed minus a quarter of t4, and you should hopefully be shouting at the screen, plus c. So I forgot my plus c in the line above, and I've remembered to put it in there. Okay, so be very careful with that. So to be successful here, you need to rewrite fractions and surds, or fractions and roots as ax to the power of n. You also need to multiply out brackets and split up fractions. Okay. You also need to be very careful with your fraction work when you're messing about with fractional powers.